Hello, I'm Robert Holmberg. I'm a member of Science Outreach Athabasca, and this is a presentation entitled Nature's Waterworks, How Lakes and Rivers Function. And this is a fairly long presentation, so I've divided it up into 7 parts. This first part is on the Earth's water. So I'd like to make a few opening statements, and this is one of them, that water is essential for all life. All living organisms require water. And our livelihoods directly or indirectly depend upon water. And the third thing is much of our recreation involves water. And the fourth thing is freshwater supplies are extremely valuable, easily ruined, and require protection. And in order to protect them, we need to know how they function. And that's the raison d'etre for this presentation. So here's an outline of the 7 parts. And the first part is the Earth's water, the hydrosphere. So here's a depiction of what a water molecule looks like, with the 2 hydrogen atoms depicted in white and the oxygen atom depicted in red. So we can look at the world in many different ways, and this is one way, and this is an interaction of 4 concepts. And the first concept is the hydrosphere, which we're talking about today. So all the water in the world, but with that is an overlap with the atmosphere, and then there's the lithosphere, the solid part of the Earth's surface. And then the biosphere, the living organisms. And all of these things interact with one another. So the Earth is really a water planet, and in that 70% of the Earth's surface is covered with water. But most of that water is salt water. So about 97%, some people say 98, no, there's 96. But in this depiction, we're going to be using 97. So only about 3% is fresh water, and that's what we're really interested in. And of this fresh water, 79% of it, or 79 of 3%, which that number there is frozen, and this is called the cryosphere, the frozen part, and it's divided into 6 different parts, which we're going to cover: the sea ice, ice sheets, ice shelves, snow, surface ice, and frozen ground. So if we look at the southern hemisphere, you can see that the sea ice is extending out from Antarctica. It's floating over the ocean, and then there's the ice sheet, which covers just about all of Antarctica. So that's the southern hemisphere. This is the northern hemisphere. The sea ice is around the North Pole, and the ice shelf is most of Greenland. So an ice sheet is defined as several ice fields melded together, and they have to be over 50,000 square kilometers, and that's just the definition that humans use. And so there's only 2 of them, the Greenland and the Antarctic ice sheets. So these cover about 10% of the land surface, not the ocean surface or the whole surface, just the land surface. So they're fairly extensive, but they're seasonal. And it's estimated that if all of the ice sheets melted, the ocean would rise at least 70 meters. And that would inundate most coastal cities and a lot of countries. So an ice field is several glaciers and ice domes that meld together. And this is an example of the Columbia ice field between the province of Alberta and the province of British Columbia. We'll come back to this a little later. So now we move on to ice shelves, and ice shelves are extensions of ice sheets that go onto the ocean and are again also floating. And in this depiction of Antarctica, the dark blue are the various ice shelves. And then we move on to snow and the frozen surface of lakes and rivers and wetlands. And again, this is seasonal. And on the 6th is frozen ground, and this can be seasonal as well, or it can be permanent, and that is called permafrost. So you can see the pink in the northern hemisphere is permafrost. So it's a fairly large extent. Now, one of the things people think about too is the last glaciation, when we had far more glaciers than we have today. And you can see from this depiction of the maximum extent of the last glaciation is that most of North America, Greenland, and Northern Europe were covered with ice sheets. And the other glaciers were scattered around the world in high regions, especially you can see in the Himalayas. So these all melted between 21 and 14,000 years ago. And so the cryosphere is shrinking. This is a depiction of the Athabasca Glacier. And if you look at any glacier in the world today, just with a few exceptions, they're all shrinking. And you can see landmarks that are depicting where they were in a few years previous. Okay, now we're moving on from the cryosphere into groundwater. So it is 29% of the 3%. Now, groundwater is a saturated zone of the Earth's surface, and it's in the cracks and the pores, and the top of it forms the water table. And the water table will go up and down, but anything below the water table is called is groundwater. And a spring is nothing more than groundwater that is merging to the surface. So this is an example of a spring. Now, groundwater forms areas that we call aquifers, and they require porous rock or sand, and they're fed by surface recharge areas. And most wells are going into either shallow or deep aquifers. So these aquifers are tapped in by humans, especially for agriculture. These are two depictions, aerial sort of depictions. The one is from an airplane and showing southern US in the wintertime, and those round circles depict where agriculture is using a central well and coming up with a big pivot that irrigates the areas. And the other illustration is a satellite image of Saudi Arabia, where they're going into deep aquifers and using agriculture. But these deep aquifers require thousands of years to recharge. And so in Saudi Arabia, if they continue with this, the aquifer will be depleted in a few years. Now, in the province of Alberta, the Alberta government is starting to look at aquifers and trying to map them out. And right now it's got over 250 observation wells. And but this is just scratching the surface. There'd have to be a lot more in order to figure out the extent of these and how much water are in these deep aquifers. Okay, moving back to the same diagram, we're looking at 1% of 3% is surface water. So we've covered the cryosphere, we've covered the groundwater, and the last little bit is the surface water. And this is divided into several things. One is soil water. So 38% of 1% of 3% is soil water, and this is what most plants depend upon. And then 8% of 1% of 3% is in the atmosphere is water vapor. And 1% of 1% of 3% is water in living organisms. So the plants and animals in the whole world. And when I talk about organisms, we're talking about bacteria, We're talking about the various kinds of protists, the fungi, the plants, and the animals, including us. So back to this diagram again, the same amount of water that's in living organisms is in rivers. So 1% of 1% of 3%. 0.00003% is in rivers. In lakes, it's quite a bit more. It's 52% of 1% of 3%. Now, we all know from even our elementary school that there's the water cycle with evaporation and condensation and precipitation, and it goes in a cycle. In reality, the water cycle, or the hydrologic cycle, if you want to get more technical, is quite complex. So because the Earth's surface is covered more by the oceans than the land area, more evaporation and condensation occurs over the oceans. And now a lot of it does fall back into the oceans, but some of it moves on to land. And although land has some evaporation and transpiration from plants and condensing and precipitation, a lot of the water that is precipitated on land actually comes from the oceans. Okay, so this is the end of looking at the total Earth's water supply. The next one we'll be dealing with transitions from dry to wet. So if you want to learn more, please click on the second part of this presentation. Thank you.